Thanks for clicking on Global Warming is Real, Highlights from the Data. The objective of this video is to help you, the viewer, become aware that global warming is real and we are the cause. In this presentation, I will highlight the most important data and contributing factors affecting our climate system. I will then tie them together to show you without a shadow of a doubt that human activities have brought this about. As I've stated before, each topic I will only mention the most important points. However, you can pause the video to read the additional information. I want to start by showing you this night view of Western Europe from space. We dominate this planet from the North Pole to the South Pole. This is important because we need to grasp just how large of a footprint we have on this planet. The human race has a direct or indirect impact on 83% of the land surface and a considerable impact on the oceans. It should be no surprise to anyone that we are changing the Earth's environment. At the very foundation of the global warming issue is the greenhouse effect. Without the greenhouse effect, the planet would be too cold for our species and our food supply. However, in the past several decades, it has become a problem due to the large increases in greenhouse gases. The greenhouse effect is a natural phenomenon caused by the presence of gases such as carbon dioxide, methane, and nitrous oxide, whose molecular structure allows them to trap energy from the sun in the form of heat energy. The levels of greenhouse gases have been increasing for the last 240 years. Carbon dioxide is by far the most abundant and long-lived greenhouse gas. Its atmospheric levels have increased by 41% since about 1755. This increase represents 2 trillion tons of additional carbon dioxide that has been released into the Earth's climate system since 1750. Data from the Law Dome ice cores in Antarctica give support to the origin of the source of carbon dioxide in our atmosphere. The upward trend started after 1750 with the advent of the Industrial Revolution. So what happened during the Industrial Revolution? Innovations in technology spurred worldwide trade and in turn increased our usage of fossil fuels like coal, oil, and methane, all of which release carbon dioxide when they are burned. This clearly points to the human race being responsible for global warming. In this graph, anyone can see that the planet is warming. Since 1880, global mean temperature has increased by 0.85 degrees Celsius or 1.5 degrees Fahrenheit. This seems like a small number, but consider this. It's for the entire planet and not just for your local area. Furthermore, there are many different environments on our planet, from the poles, the deserts, and to the tropics. A 1 degree global change is very significant because it takes an enormous amount of heat energy to warm all the oceans, the land, and the atmosphere. In the past, it only took a 1 to 2 degree drop to plunge the Earth into the Little Ice Age. A 5 degree drop was all it took to bury a large part of North America under a massive ice 20,000 years ago. Our planet is 70% water and 93% of that heat energy has been absorbed into our oceans. I hope this gives you a new appreciation for our oceans because right now, they're the only thing saving us from running our air conditioners year-round. Since 1978, satellites have been orbiting the Earth measuring the amount of energy being trapped in the Earth's climate system. The results indicate that the Earth is retaining more energy than what's escaping into space. Climate researchers have identified the cause of the energy imbalance. The biggest culprits, you guessed it, are the 3 gases carbon dioxide, methane, and nitrous oxide. The current energy imbalance is 2.3 watts per square meter. Once again, this indicates that our planet is warming. So where is all this carbon dioxide coming from? This graph shows how CO2 emissions from the burning of fossil fuels have increased over the past 150 years. In 2010, we emitted about 37 billion tons, that's billion with a B, of CO2 in 1 year. By 2030, it's projected we will be emitting 45 billion tons of CO2 per year. These are epic amounts. To illustrate this point, I compare 40 billion tons a year of CO2 emissions to the weight of the human race. 40 billion tons is 114 times larger than the total weight of the entire human race living on the planet right now. In this figure, we can see from the Mauna Loa Observatory in Hawaii that atmospheric levels of carbon dioxide are increasing at the same rate as our fossil fuel consumption. So take a wild guess at who's responsible for this increase in CO2. So what's increasing our usage of fossil fuels? In Figure 9, we take a look at the growth of the human population. It's clearly growing at an exponential rate. In addition, there's always a desire for a higher standard of living in many regions of the planet. The current population data shows that the net increase in the human population is approximately 75 million people every year. Of course, this means more fossil fuels will be used, and as a result, larger and larger amounts of carbon dioxide will be released into the Earth's climate system. So let's look at the other possible causes of global warming. The three most commonly discussed causes are the sun, orbital forcing, and volcanoes. In the next 3 slides, I'll show you data related to each of these possibilities. However, a detailed discussion is beyond the time limit of this presentation. Suffice it to say that the experts point out that the current output of the sun, the volcanoes, and the Earth's position in its various orbital phases are not the source or even have any major impact on the global temperature. So that only leaves the human race as being responsible for global warming. I've summarized the only conclusions at the bottom of each slide. Feel free to pause the video and look over the details. Once again, please feel free to pause the video to read over my comments. So what about volcanoes? Here you see the eruption of Mount Pinatubo in the Philippine Islands in 1991. It was one of the largest eruptions of the 20th century. But what is a volcanic plume cloud made of? Most of the plume is water vapor and not carbon dioxide. During an eruption, the other major gas is sulfur dioxide, which is not a greenhouse gas. In fact, it sometimes causes global cooling by reflecting sunlight. Sulfur dioxide does produce acid rain though, which is very harmful to the environment. But the facts point out that human carbon dioxide emissions for 2010 were about 130 times that from volcanoes. So let's do the math. 33.6 billion tons of carbon dioxide per year from humans compared to 0.26 billion tons a year from volcanoes. Surprisingly, volcanoes are no competition for the human race. So what will be the outcome of our massive use of fossil fuels and carbon dioxide emissions? The Worldwide Climate Research Organization, known as the Intergovernmental Panel on Climate Change, or the IPCC, has come out with 4 major scenarios. I'm going to discuss only 2 of these scenarios, the Representative Concentration Pathway, or RCP 2.6, which is the best case scenario, and RCP 8.5, which is the worst case scenario. RCP 2.6 is the best case scenario. On the left is a table showing by decade how our CO2 emissions from fossil fuels must change. The corresponding data is also in graph form on the right. Please notice that we will have to reduce our fossil fuel dependency to below 0 by year 2100 if we want the global mean surface temperature from rising above a 2 degrees Celsius or a 3.6 degree Fahrenheit increase since the Industrial Revolution. It won't be easy, but this is the best and only option if you ask me. If you thought that RCP 2.6 was bad news, then buckle up and get ready for the really bad news. RCP 8.5 is the pathway we are currently on and has been dubbed the business as usual scenario. If we follow the RCP 8.5 scenario, then by year 2100, the energy imbalance will reach about 8.5 watts per square meter, which is 3 to 4 times higher than our current energy imbalance of 2.3 watts per square meter. Please notice the table and graph that over a 90-year period we will go from emitting about 30 billion tons of CO2 a year to over 100 billion tons of CO2 a year. That's an increase of over 200%. That's insane, but that's where we're headed right now. By year 2050, just 34 years from now, the global temperature could reach an increase of 2 degrees Celsius or 3.6 degrees Fahrenheit above the pre-industrial age. That's considered the warning zone. By year 2100, the temperature will continue to increase to about 3.7 degrees Celsius or 6.3 degrees Fahrenheit, which will put us well into the danger zone. By year 2300, temperatures could increase by 8 to 12 degrees Celsius or 14 to 22 degrees Fahrenheit above the pre-industrial age. These temperatures will have a major and permanent impact on the Earth's climate and life forms. Currently, we are on the path of RCP 8.5. If the IPCC's projections for global temperatures for year 2100 are correct, then we're in deep trouble. So the question isn't if it will happen, but how hot is it going to be? So please ask yourself, will I take steps to reduce my fossil fuel usage? Because this issue has become so mixed up and deadlocked in politics that it's truly up to us as the individuals. Connecting the dots, we can all agree that human impact on our planet is huge. Global warming is real and is caused by gases such as carbon dioxide. These levels have been increasing since the Industrial Revolution and the invention of the internal combustion engine. Data from the Law Dome ice cores show that carbon dioxide began increasing around 1750 with the start of the Industrial Revolution, which proves we are responsible. Records also prove that the use of fossil fuels have increased at the same rate as carbon dioxide. Our addiction to fossil fuels is being driven by our growing population and the desire for a better standard of living. The IPCC's projections for RCP 8.5, business as usual, will increase the energy imbalance by a factor of 3 to 4 times higher over the current imbalance, which will bring on very high temperatures and more erratic weather around the globe. Can we adapt to higher temperatures? Humans can always adapt, especially with our artificial environments, but our crops and food sources can't. There is a range of uncertainty in the data. However, if we continue to emit 40 billion tons of carbon dioxide into the climate system each year, sooner or later we will reach a tipping point to which the Earth will permanently be damaged, if that hasn't already happened. But it's never. So why all the confusion? The Intergovernmental Panel on Climate Change, better known as the IPCC, or the unbiased experts, are saying that global warming is real and we are responsible. On the other hand, the deniers are saying that global warming is either a hoax or a scam. Just follow the money, as they say, and you'll quickly see who and why they are creating the lies and subterfuge. The skeptics, unfortunately, are caught in the middle because of this misdirection and lack of clear and easy to understand facts on this issue. Please read or watch the following resources for more insight to why anyone would want us confused and indecisive about the fate of our planet. Also, you can watch the detailed presentation on global warming down below on the hyperlink. So what can I do? Obviously, we're not voting our way out of this problem fast enough to prevent permanent damage to the Earth. But remember, we are the fourth branch of government, and we need to enact permanent change with our local, state, federal, and even global officials. They're just a Google search away, so please contact them and vote in the next election. What can a homeowner do to reduce their energy consumption and costs? Wash your clothes in cold water, replace incandescent light bulbs with fluorescent or LED, supplement your electricity needs with wind or solar technology, purchase a hybrid car and hybrid bicycle, purchase a tankless water heater, install a geothermal heating and cooling system, install energy-saving window film. Please note that all of these solutions save you money and can also make you money. In some regions of the country, solar collectors produce more energy than used for a single home and is automatically sold back to the power company. What can someone who rents or a younger person do? Most of the above options still apply, but it doesn't hurt to ask your landlord or your parents to make larger improvements. Show them the money-saving aspects, because every one of those suggestions will pay for them. Regardless if you're on a nuclear or coal-fired electrical plant, we need to reduce our carbon footprint as individuals and be the solution and example to our friends, family, and the world. And by all means, let your elected officials know that you want action. Thanks for watching.